Now, as hinted at earlier, but not really covered in detail, these maps have hills on them. And since these are nice smooth curves, you've got to be able to draw that in the game. So first, let's think of the obvious. This looks sort of like a polynomial with a high degree. So let's see what the polynomials would look like. So here's the linear. I'm just going to approximate here. Here's the linear. Here's the quadratic. No, let me draw this again. Linear, x and y axes. Quadratic. And here's the point 1, 1. Cubic. Quartic. And I'm exaggerating here, but you notice that that the higher degree the polynomial, the more it's going to start out flat, and then it'll suddenly take this steep curve. So if you're going to try to draw a hill as a polynomial, so start with a quadratic, to counter this thing, the cubic part of the equation is going to have to take this sharp turn down, and then the quartic part is going to have to take this even sharper turn up. So then, even if the points on your hill are defined like here, 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 and here, then to do the higher degree after that, you'd have to make the hill look like that, or something like that. So polynomials aren't going to work well. Instead, what you use is called a spline curve. And a spline curve so you've got the points on the hill. The spline curve is going to say that each segment between these points is defined by its own polynomial. Now, a quadratic equation can be defined by using 3 points, or by using the starting point and the ending point and the slope. So you can take this left to right, but what's going to happen is that since you can't set the slope of this, it's going to have to counteract that over here, and it's going to have to counteract that over here. And then even if you have these fairly straight points over there, since this slope's extreme, it's going to have to counter it like that, and then like that, and then like that, and like that. And in general, that's not going to look very good. So instead, what you use is a cubic function, because a cubic function can be defined as you could take the 2 points and give the slopes on both sides, and then define a cubic function for it. Now, the formal name for these piecewise functions are called spline curves, and the specific case with these cubic functions are called cubic spline curves. Now, when we found this quadratic one, let's just take 3 points. There's the slope of the left. Let's just say it looks like that, and here's the middle point. And the slope over here has to be the same for the function on the left and for the function on the right. Now, the slope at the point in calculus terms is called the derivative, and in this case this is the first derivative. Now, for a cubic spline curve, you'd want the first derivative to be the same on both sides, and the second derivative to be the same on both sides also. So then you could just modify the x cubed part of it to make the equation. But these hills aren't in 1D, they're in 2D. So the way they'd be defined is that you have, most of the time anyway, is you'd have this grid of points, and then you say the height of the map at those points. So then you find the cubic spline curve going for each of these lines. Oops, sorry about the bad drawing. And then to find the heights of these points in between, you take an average of the, so let's say we're finding this point, you take the average of the height over here with the average of the height over here, and then you've got yourself this nice smooth looking 3D map. So let's say we've got it looking like this now. In an actual game, you won't just want to find those center points, you'll want to find a lot more also. But now we have to draw it. So in computer games, you always want, practically all the geometry is made out of triangles. And to optimize it, what's often used are called triangle strips. So I'm going to number these points here. So you'd input the points like that. And then for the first triangle, it takes the first 3 points. And then for every triangle after that is based on the next point and the previous 2 points. So it would look something like that. So now we want to draw this triangle strip on here. So let's take this one row at a time. The way you do this is you go like this. Simple. Point 1, point 2, point 3, point 4, point 5, point 6. You see the pattern? So then I'll create one triangle like that, and the next triangle like that, and then the next triangle like that, and then the next triangle like that, and so on, and then you do that for every row. Now another important element of RTS games is that the hand-to-hand combat isn't the only type of combat. There's also projectiles. So let's say you have a person here who wants to shoot a projectile at a person here. Of course the path of the projectile is pretty simple since it's just a quadratic equation. But the tricky part is finding what velocity to shoot it out at. So first of all, we're given the height of these people on the hill and the horizontal distance here, which can be solved for in 3D, and the fixed speed that the projectile comes out of. And we need to solve for the x and y components of the velocity, which is a very difficult thing to do. So so after failing to try to derive this myself, I looked up for hours on the internet for how to solve this, and eventually I gave up and just went to Wikipedia. And I found it within 5 minutes, which shows that Wikipedia is quite a useful resource for finding things, just as long as you don't need to prove it like in a research paper.